Welcome to Plutus IAS, and today we are covering Zimmerman's rearrangement. Now, Zimmerman's rearrangement is more popularly goes by the name of Zimmerman di-pi rearrangement reaction. Now, this reaction is part of your photochemistry syllabus of the organic chemistry as in your paper number 2. Organic chemistry for your paper number 2. Okay, now this Zimmerman rearrangement we see mostly look for your 4 pi electron system. That means we will be talking about dienes. Now, what does Zimmerman's reaction separates itself from different types of rearrangement reaction that we know, like 3,3 sigma tropic rearrangement, 1,4 rearrangement, other type of shifts? How it is different from them? So, what separates Zimmerman's from other types of rearrangement reaction is the set of conditions or rules that it imposes. The condition number 1 that it imposes that you should have a diene system. Number 1, you should have a diene type system. Diene system. That's condition number 1. Condition number 2, that these two dienes or pi bonds should be separated by at least by one carbon. If they are not separated by one carbon, that means most likely other types of rearrangement reaction can prevail and the reaction path will change itself. So for second condition, what it states, the second condition state, they should have separated by one carbon. Separated by one carbon. Okay, so that's your 1, that's 2, that's 3, that's 4, and that's 5. Later on, it further imposes condition that it can work by direct, if you are going for an acyclic system, only direct irradiation can cause this rearrangement. If you go by sensitized irradiation, that means you are using a sensitizer. Sensitized radiation will give you cis to trans isomerization, and in that case Zimmerman will not be followed. Next condition that it imposes, that whatever the alkene that you have, it should have at least at one point, it should have at least one terminal pH group. Later on, it further emphasized that this particular carbon should also have methyl carbons for increased reactivity. Only then, in all such conditions were followed, only then we'll say that Zimmerman rearrangement is possible. In case of any of the following condition being missing, we'll say that other types of rearrangement reaction can also take place. So let's move it further with an example right here. So what does it mean? So Zimmerman reaction in short tells us about Zimmerman rearrangement tells us about that if you are having a diene, your diene system, it will convert itself to a vinyl cyclopropane type system. Vinyl cyclopropane type system. This mechanism works on radical mechanism. That means for the reaction to occur, the stability of the radical is our prime responsibility. As long as we are maintaining the stability of the radical, we can say that the reaction will proceed and Zimmerman rearrangement will be achieved. For example, so let's suppose I take this example. I have this diene, I have attached pH right here, there is also a diene, and let's have attached methyl group here. So now the option is, if I provided radiation, it's very important that direct radiation should be mentioned. If direct radiation is not mentioned, that this trans compound will become cis and cis will become trans. So here I'm writing direct. So that means it will convert the pi bonds in the form of radicals. One radical would be here pH will remain like this. Sorry. And in this case, radicals will remain like this. So this radical will bind to one another, giving you a cyclopropane. But the reaction will not stop at this particular point. Now the question arises. Since radical stability is our prime motive, the problem is the radical which is generated here, this is a primary radical. That means it is not very much stable. So we need to stabilize it. So now I have two options. I need to generate another the radical, and I have option number A and option number B. Let's suppose if I break bond from point A. If I break bonds from the point A, it will give me a tertiary radical right here. Wait, sorry. A tertiary radical here. The carbon here, another carbon, and let pH is here. Okay, this bond right here, it will form a pi bond, and another radical is here. Now the only option is this radical is being stabilized by the pH group here, and this is tertiary radical more stable. So they will combine together to finally give you the product which look like this. pH. Now remember, this is a stereospecific reaction. That means if pH is on the opposite direction, the pH will remain on the opposite. If it was cis, it will remain cis to the reaction. Now, if I go by side B, so for the side B, if I break bond right here, the condition arises as, again, I will get a radical, tertiary radical. In this case, the pi bond will be formed here. With the pH right here, and I have this radical here. Now, this can combine with this radical. Wait a minute. I think I have added more number of bonds here. Bond, carbon, this carbon, then pH here. Okay, this will form double bond here. It will form a butane. Wait, am I making? Wait, no. This carbon would be here. Okay, so this case the radical can pull up here, and it will give you like this. This. Now, this point here, this radical, this is not found. This is not observed. In this type of reaction, the radical stability is of our prime importance. So in this scenario, if you see here, the combination of radical at this particular position, this radical is not stabilized by any kind of means. Hence, this state will never be formed. Hence, this product will never be observed. While in this case, the radical that I got was a tertiary radical, and the radical here was stabilized by the pH group. So what do we know? That the prime importance for Zimmerman reaction is the stability of radical. If you cannot get a stabilized radical, that means the reaction will not go down that path. Hence, in this reaction, the only product that you will get will always be in terms of wedge or dash. Otherwise, the single only one type of product will always be observed if you're not considering the stereochemistry. So I hope now all your doubts regarding Zimmerman reaction would now have been resolved. Now, what you need to remind always yourself that these are the conditions. If any of the condition that is I have written here, if they are not being followed, Zimmerman reaction will never ever occur. For Zimmerman to occur, all these conditions needs to be fulfilled first. Okay, so I hope this has cleared all your doubt now, and we'll see you in the next video. Thank you for joining us.